All right, so see you again today. In the start lesson, we will have a revision on Rust. Okay, so just give you a recap. I said before, you have got a test this week. Don't tell me that you don't remember. Okay, when you're along this Friday, what topic would you like to have a test on? Rusting or the reactivity of metals?
Whatever lah.
Or whatever. Okay, why not both? Is it okay to have both?
You like lah.
Okay, you dare not suggest anything, huh? Tân Chuẩn Hy?
Or
Or? Or? So, let me see. Today's date. Oh, I forgot. Is it? Oh, I forgot today's date. Is it? Day 2, day 3. Day 3. Because I need to mark the attendance. Oh. Okay. How about testing the concept of metal first of all? Okay, metal. So both chapters need memorization. It will add to certain level of difficulty in managing that. Okay, so we'd like to test it topic by topic. Period. Yeah. Okay. So let me see if all of you have come back. Trần Hỷ Thịnh.
I'm here.
Yep. Hello. Trần Hỷ Thịnh. 27 guys. There should be all of you are here, is it? Trần Học Ca. Trần Kiệt. Yep. Hoài Lập. Lê Bùi Hận are here. Tân Trần here. Tân Hữu Trân are you here? Còn Trân Huy, còn Nhật Long, Jen Học Mình here.
Yeah.
Yeah, here. Okay. And Francie White.
Hello.
Phùng Cá Hiếm. Phùng Cá Hiếm not here. And Hồ Hao Dập.
hello.
Yeah. Hồ Lại Dịch.
Yes.
Quang Trân Hy.
Hello.
Hôm nay.
Hi.
Lê Trạch.
Hi.
Lâm Cao Kiệt. Lâm Cao Kiệt.
係啦。
All right. Lê澤Sinh.
Hello.
Hey, Lê Yên樂.
Hello.
Mà Cao Lộc.
Hello.
Hòn Nhật.
Hello.
Ngài Trần Thâu. Ngài Trần Thâu here. Okay. So, or two more guys. Are you here?
喺度。
Thàm Quân Nhậu and Wang Sang Hin. Are you here? Wang Sang Hin? Not here? Anyone who find Wang Sang Hin?
喺度。
Oh, all right. So
Hello.
I repeat. Is it Phùng Ca Hiêm? Absent. Phùng Ca Hiêm. Phùng Ca Hiêm. Second time, third time. Phùng Ca Hiêm. Okay. Absence. Okay. Now today, we would like to have an overall revision on chapter 13. Okay. Do you find this chapter difficult? Not really. but you should know some of the key points about this chapter. I would like to get you some address. Now, when you compare to the chapter reactive of metal, it's also talk about the chemical reactions of metal, but we focus on a very rather slow reaction. Okay, deterioration. Okay, and especially a type of slow deterioration of the chemical of the metal caused by the chemical interaction with oxygen, moisture, which means water, and other substance in the environment. We call it corrosion. Okay, so this is what you know about corrosion. Now, corrosion and rusting is just a big circle and small circle. Okay, corrosion is here, while for rusting is just here. Okay, so what is the difference between corrosion and rusting in terms of wordings? And
Yes.
Yep. What is the difference between corrosion and rusting? You have to solve it, right? By typing on the web and search, right? Can I have梁家傑? Tell me the difference between corrosion and rusting.梁家傑. Are you here?
Corrosion 係好似大部分 metal 都係，而 rusting 就係即係 iron 啦。
So you pinpoint the use of these terms to tackle the oxidation of metal, right? All metal, while you react with oxygen or water or some other substances, and we call it corrosion. And for rusting, it's just what? The corrosion of what? Rusting. It is what? Corrosion of what? Of iron. Okay, so this is a very special term. Can you get my point? So you can never change the use of this term if you want to talk about rusting. Okay, so 生鏽. So 生鏽. So why is it 鏽? 鏽. We call it rust. It is something like a reddish brown crust. So if you want to talk about as 鐵鏽, so we call it iron rust. Okay, but of course you may think of some other term which borrow the same thing. We call it 鏽. For example, have you ever heard of the term 銅鏽? Have you ever heard of the term 銅鏽? Have you ever heard of that? The answer is yes in Chinese. But what is the color of 銅鏽? Do you know what's that? What is the color, Lei Cheng?
I don't know.
You don't know. You take a look on the book here. 銅鏽 on the right hand side of the book here.
Oh, okay.
Yes,
green.
it's green. It's green. So even as said before, even if you want to talk about, so it is a type of green patches, right? Found it on here. And even if you want to talk about texture of Buddha, so you may find it as some green patches. Do you find it? Now this is the one. Now, so the one you find it on the Lantau Island. So we have got some green patches, especially right on some area, just like here. just like here. So you may find some green patches, but if you stay there for long, like it's not a copper stature. Now, can you see that from this angle? It's also the big Buddha. You may find some green patches, especially either here, right, curly hair. While here we have got some. Why is it green here? Why is it's usually found as green instead of some other places?
Surface area is bigger.
Yeah, surface area is larger, and it is also with a concave, right? Some holes there, so it would trap some moisture inside, which will speed up the corrosion. So if you place it for long, the structure will become like this. Okay, the structure will be like this. This is the one you find it in Japan. In Japan, okay, we've got some bronze structure. Bronze. Do you know what's the mean by the word bronze? Bronze. In Chinese, we call it 青铜. So why you call it 青铜? It's because while it corrodes, it will form some green patches. Okay, 青铜. It is a bronze. It is an alloy of what and what? Copper and what? Tell me. Copper and what? No need to air. You can search it the web and you can answer.
哦，好啊，好。
點啊 ？hea 我，長學家。
give me a minute.
Minute. Who can answer that? Zinc, tin, lead, aluminium.
Tin.
Mainly tin. Okay. Copper and tin. This is the one. While the very often we have got another for comparison is the brass. Okay, brass. Who is the member of brass band? Tell me. Who?
鄧浩俊啦，鄧浩俊。
鄧浩俊啊 ，brass band.
Hey,
in order to label yourself as brass band, you should know the chemical composition of brass. Otherwise, you'll not be qualified to call you yourself brass band. What is that metal that made up of brass?
Copper 同聲。brass copper 同聲。
Copper and zinc, good. 果然係 brass band Okay, so and you may find this. So why you call it 青銅 is because of the color. It's because of the color. It will cause some green patches if you place that alloy for long. Okay, where you may find so many antiques. Okay, whenever you see green patches, I do think if it is bronze. Okay, is that clear? So this is what I'd like to share with you about the daily life, about chemistry, and the products of the corrosion. Why do we need to get so afraid of corrosion? Okay, why? It's because of what? Once it's corroded, what will the property of the material? We will call that deterioration. So what's mean by deterioration? Something bad. Okay, something bad. So in terms of properties, so it's not just the appearance will be affected, but we have got some coating, some flaky substances. We call it rust. But one thing that we may find it's very terrible is that it is brittle. It's brittle. So while you compare with uncorroded iron, it's set as strong, set as hard. But once I change to rust, it is set as brittle. This is what we don't want. So especially while you are having the iron object, we will have their own uses, just like bridges, building material, okay, etc. So it may be added some about the safety concerns. If it is brittle, which means that they cannot withstand so much force, so much weight. So all of a sudden they will be broken down. So this is what we scientists, but also the people, the general public, will pay much concern on it. Okay, so it is something about money. If you want to go back, it is what we want. You have to do. We have to preserve the form of iron. Okay, but sorry, according to our nature, iron will finally go back to its most stable state. It is rust. So we are now going to have a competition with nature. Have you for somebody who are you're just saying about in Chinese saying 我哋逆天而行啊? Why you say that 逆天而行? You can get what I mean, right? Because you are going to do something in reverse, okay, to oppose something occur naturally. Rusting is a natural process. Okay, why? Because iron 3 oxide, hydrated iron 3 oxide is somewhat more stable. Do you understand the whole flow? Okay, so that's why we need to think of some protection method to slow down or even stop their corrosion. While it will affect, it's not just safety and also the cost. And in order to get to know more about that, you should know the conditions for rusting to occur. So you may see this diagram. So please put a star here, and this is some work you need to pay much attention to the design of experiments, to the purpose of affecting those chemicals, as well as the results. So the result should be the essential factors is oxygen, circle them, and water. So we need both of them present in order for the iron to rust. And the second one, because for the rusting process, shortest time you can see it easily observable is 1 or 2 days. It depends on the humidity of the RNL or in the surrounding environment. And if it's very humid, just only 1 or 2 days and you can see signs of rust. As said before, it's reddish brown. But it will wait for you for so long a time. So what can we do is to, why not, spotting the most crucial steps. Okay, if the crucial step has started, which means that the rusting will occur. So what is the crucial step? This is the first step. Okay, this is our first step, half of the first step. This is the reaction between the iron. They will lose electrons. Okay, they will have a losing of electrons. So all together, and if we can at the same time, the essential factors, oxygen and water, they will receive the electron loss from the iron to form hydroxide. So both chemicals are present in the very first step in the chemical reactions, and we are going to spot them out. Okay, so that's why we have got the rust indicator, which will have got 2 components. Each one of them is used to test for each component. For example, potassium has a cyanothread test for iron 2. Phenolphthalein is used to test for hydroxide. And they will turn the color blue and pink respectively. So what is that blue? A very special blue. Have you ever heard of the term Prussian blue? 保魯士藍. Okay, so it is the color that you may find in some countries, right? They were very famous of having produced that blue. Okay, Prussian blue. And hydroxide, once it meets with phenolphthalein, they will turn something pink. Okay, some will turn something pink. And by having the indication of the first tier reaction, okay, what I mean is a hydroxide and iron 2, we would say that if I can monitor the first step of the reaction, we would have much belief that they would have the consequence chemical reactions such that the iron will form rust. So that two equations you should memorize, and these equations should also be memorized. In between the step is too complicated, so I don't want to spend too much time on that. Just focus on this. Okay, so this is what you know about the rust formation and the equation, and this is what the chemical nature of rust. Can you see that X2O? What does it mean by that? The water molecule, they are surrounding the structure of iron-3 oxide. They're embedded. They're just they're just being one part of the union. We have got iron-3 oxide and also water molecules that have a fixed ratio to form this substance we call that rust. And this is what you have to know. How about 13.4? And we need to get to know some of the factors that speed up the rusting process. So what are the use of this? In case you get to know the factors that speed up the rusting process, we can know how to have a rust prevention method. Of course, you may think in reverse, right? You may think of factors that can slow down the chemical reactions. Can you get the logic? If I know some factors will speed up, I know some factors can slow down. So we look for slowdown and prevent some factors that may speed up. By doing so, we can, sorry about that. Yep. And by doing that, we can prevent the signs of rusting. For example, while you go to seashores, you may find some iron chains or iron object easily go rust. Is because of salt vapor in air. Indeed, while you stand near the seaside, you may have some sea breeze, right? But you may also have got some salt powder, right? That mixed with the water in the water vapor. So for somebody, we may have an experience that your hair, while you have got dry, even though you did not jump into the sea, there may be some signs of salt. Okay, it's salty. Okay, if you rub it and then you better not taste it, but you can sense it some powdery, something powdery is salt. While with the presence of it, it will speed up the whole process. Why? Anyone can tell why? Why do the presence of salt speed up the chemical reaction? Why?
have 呢個 better 嘅 electrical conductivity
of what?
of
Displace heat need higher electrical conductivity.
electrons。
Electrons.
唔係，睇下先。
Electrons. 我問翻你點解啦？Many of you would know the fact, but you did not know the reason. Today we focus on the reason. 點解？Anyone who can help?
因為如果你有啲electrical conductivity 增加咗，因為你嗰啲 iron 會 lose electron 而 oxygen 而 oxygen 就會係咪 oxygen？ 係 oxygen 係 oxygen， 跟住就會 gain 翻 electron。咁如果你個 electrical conductivity 高啲嘅話，咁佢個 electron transfer 呢個 process 就會快啲。
So what makes it conductive? So is it the iron object itself
mobile
or the
ions
water?
of the ionic substances.
So where is it? You just say that electrical conductivity on where? On iron object, on air, on water, where?
Water, because if ionic substance dissolve in it, because this is in an aqueous solution, so there is mobile ions.
Yeah, that's right. So this is where we focus on. The salt, it will increase the electrical conductivity here and will make the process to occur in a more speedy manner. Okay, so this is what you may know about this. So maybe Mr. Lam has taught you something more about that. For example, anode cathode. Have you ever heard of the term? Anode cathode.
Yes,
So
yeah.
indeed, it is a chemical cell. In the whole process, we call that a electrochemical cell. What is an electrochemical cell, or use the word chemical cell? It is an energy converter which can transform the chemical energy to electrical energy in terms of redox. It is a type of redox reaction. So that's why redox reaction would involve the core part, right? It involves an electron transfer from one place to another. Okay, gain or loss in terms of gain or loss electrons. So very often we will talk about gain or loss of electrons. So imagine a whole piece of iron object, somewhere places in which they would love to do electrons, but somewhere places you love to accept the electrons. And it gives a place where the chemical reaction should start. So the chemical cell, what is needed, we need to have some positive pole and negative pole. So we call it anode cathode. And also we need to have something what we call it as electrolyte. Electrolyte. 電解質. So water here is called electrolyte. So just imagine that water, it seems like lemon juice. Okay, so we are going to do something like a lemon cell. Okay, but this time the two metal, in the past we think of the material having that two piece of metal and they can generate electricity. But this time the whole piece of iron, part of them is positive, part of them is negative, and they will undergo the chemical reactions. But of course, because we are now talking about the same material, so the reaction would rather go so slow. Okay, so they will find a place where they love to lose electrons. For example, can you see this part? What is that? The place where it's a large surface area. Or, and in practical sense, you may find it as bent, sharp region. Okay, or we have got the break point. For example, if you have a piece of iron, you just bend it for so many times, okay, all of a sudden the whole piece of iron object will be broken into two pieces, right? So we focus on the broken part, the place where there is a broken part. So this is the place where it has a large surface area. While this facilitates the losing of electrons there. Okay, so and for the other part, they may find some places where they will act as a cathode. So you have got the electrons crowded there, and water and oxygen will meet the electrons. They will react. They will gain the electrons to form hydroxide. Okay, so if you want to speed up the whole process, of course, the water here should be more electrically conductive. Okay, can you get my point? So I add salt to it. It will help supply what? It will help supply the mobile ions to increase the electrical conductivity. So can you get my point? The whole logic will be this. 明唔明呢度講咩? So why is it have a saying that they have got better electrical conductivity? Okay, somebody will say that there's nothing to do with the electricity. Not really. There is. We have got because the principle of it is the chemical cell. Okay, can you get my point? 有冇嘢問? And second, acidic substance. If got acidic substance is also provide ions, and also they will have a direct reaction with iron to speed up iron too. 馮家謙 Okay, thank you. Now, so higher temperature is also the one. So how high is it? Higher temperature, the chemical reaction come faster. Do you know? The increase in the temperature of 10 degrees, the rate will be increased how many times? Do you know? No?
double.
Double. Yep. Double. Increase the temperature 10 times, the rate will be doubled. So you know that calculations in Form 6, okay? So 3, as said before, it allowed stretching and bending area because the surface area of contact is larger. So it would help provide a place where the iron nail loses electrons more readily. Will you love to use that technical term, right? Lose electrons more readily. And of course, if you want to attach to a less reactive metal, it's just like the competition of the tendency of losing electrons, okay? So for example, if you have got an iron object, if you put it into a tin, for example, so this time, the losing of electrons will be of this direction, okay? Iron will lose electrons more readily instead. It will make the rusting go faster while you have it stand alone. While you want to keep it slower, you may have it, for example, zinc that direct attached to it. So the losing of electrons, the direction will be in reverse. Okay, which will make you to slow down rusting. It will speed up rusting. So this is what we call it as a control, a reference point. Okay, you get my point. So this is what you know about this. And using this, you may think of some possible ways. So altogether, and they have got 4 methods: protective coating, sacrificial protection, impressed current, cathodic protection, and also alloy. Okay, we have got that 4. Okay, so in between them, for protective coating, there are so many different things. So whenever we've got a piece of iron, whenever we have got, what is mean by coating? A complete covering, okay? A complete covering surface on the piece of iron, we call it a coating. It's up to you on the purpose. It can be paint, it can be grease, it can also be a piece of iron. Can you get my point? Plastic is also possible. So we call that protective coating, means whenever you have that another material that totally sealed, okay, sealed, 完全地包含晒 sealed, that surface in which the iron itself cannot react with oxygen and water, that cannot come into contact with it. So we call it a protective coating. Can you get my point? While for sacrificial protection, that you may have that example for the paint, plastic coat, grease, tin plating, okay, and electroplating, etc. But remember, for tin plating, it refers to applying a coat of tin, right? How? They can be 2-way. Do you know how to make the tin plating?
It's called electroplating.
Electroplating is one type. But once you type this term onto the web, you may also see the coating of metal. They would have that 2 methods: electroplating and hot dipping. So what is the difference between them? They are not the same. So what does it mean by hot dipping? Have you ever tried out? You go to the buffet and we have got a chocolate fountain, and you make a chocolate fondue. You put a piece of fruit and put it inside and take it out, right? So it is a matter of hot dipping, a very similar principle. So we have got a piece of iron object, and I put it into the hot molten metal, and then take it out and let it cool down. So it is what we call it as hot dipping. Can you get my point? So it is we call it hot molten metal, and you put that piece of iron into it and take it out when you're not hot dipping. But electroplating, you need some something what we call it as like this. So you need a electrolyte, and in which it contains that metal iron. For example, I want to coat it with a layer of silver, for example. I may get silver iron. Okay, the iron object is here. So by having the negative charge attracted positive and also providing electrons, so the silver ion, they would gain electrons to form silver, which makes a coating onto the piece of iron. So it is somewhat different. Okay, on the electroplating, I would have electricity, I have electrolyte, and I use electrical energy to generate to come with a chemical reaction. Indeed, to make a piece of metal coating on that. If you use the hot dipping, it seems like chocolate fondue, and you put that piece of iron into the molten like metal and then take it out and let it cool down. Okay, do you understand? There are two methods. So tin plating and electroplating, so that two, they are not separate methods. It depends on what tin plating they are having. Okay, it can be electroplating or it can be hot dipping. So remember, and we have got one more point is got galvanizing. Yes.
我想問咧，咁如果係嘅話，咁佢 hot dipping 同埋嗰個 dripping 同埋 electroplating 佢兩個有咩好處啊？即係佢個分別係
？What do you think? Electroplating and hot dipping. Now, hot dipping, the difference between is not the principle, but also the thickness of the piece of a metal layer. For example, for electroplating, it will use electricity. Somebody will say that is a little bit costly, okay? But if you want to talk about hot dipping, I melt that metal is also involve large amount of energy, right? So it's different. Second, if you want to talk about the cost for production cost, both are similar. Second, it's about the layer of coating, the thickness of the coating. For electroplating, it is more easily controlled. It's more easily controlled. While for hot dipping, it depends on the relative temperature between the iron object, the molten metal, okay, and the time of dipping, and it will give you different thickness. Okay, they will give you different thickness. So if you want to have a better quality assurance in terms of a thickness, in terms of controlling thickness of the metal coating, electroplating may be a better choice. Okay, but for the hot dipping, you can make it as a large production easier. Okay, because whenever you have got a molten metal in a big pond, I can do all things in a second. It will make you in a speedy manner, but the quality varies. It depends, as I said before, it depends on the temperature of the iron object. It depends on the temperature of the molten metal, and they will affect the coating. So difference between the two. For electroplating, you can control the coating, the layer of coating. For example, the voltage, as well as the time of electrolysis. Okay. So the quality is a little bit different.
好好唔該。
Okay, so sacrificial protection. So this one, galvanizing, is another thing. Now, so remember, galvanizing itself, it also belongs to protective coating. All of you, could you please mark it down? Or galvanization, you have that term, galvanization. Okay, so it should be belonging to this category, protective coating, but not sacrificial protection. Now, this is what I would like to clarify with you here. Now, so unless we have got something broken or something stretched area, and sacrificial protection would perform it as a sacrificial protection. If you have got the complete sealing of the iron object by a layer of zinc, okay, it is we will call it galvanizing, while the rust prevention method, what we call it as what? And it is a type of a protective coating. It's like a protective coating. So for zinc, you may find it difficult to have it electroplating because zinc ions, they are too stable. They'll be less easily reduced. So for galvanizing process, it may needs hot dipping. Okay, so this is what I would like to share with you. Somebody, they want to ask you one more point about the difference between hot dipping and galvanizing, right? And electroplating. Is that, for example, if you want to coat a piece of silver into it, you will easily use electroplating. But because silver iron is rather unstable, they want to go back to silver. Okay, but if you want to melt a big tank of silver, that you want to make hot dipping, so what will happen? I need a big pond of silver. So try to compare the electrolyte and the whole pond of silver. Which one is more costly in terms of buying raw materials? Of course, you know it, right? You can get what I mean. So it is also related not only about quality, but also the cost, the raw materials, right? What will happen if I have copper? For the solution, I have copper 2 iron solution very easy. But we've got big tank of copper, wow, very costly. No need to mention melting point of copper. Do you know what is the melting point of copper? How many degrees? More than thousands, more than 1,000. So you may add it to the cost. Okay, so galvanizing, remember, whenever you have got when the protective coating doesn't work, okay, you need to think of a sacrificial protection. And for this part, instead of replacing the whole ship, bottom of the ship, we would love to replace the zinc block instead. Okay, 你冇理由成架船走去換咗佢。Okay, so because why not just replace the sacrificial metal? And also the underground pipe. Instead of replacing the whole steel pipeline, why not just replacing a bag of magnesium? Can you get the whole logic? Okay. So this is what I would like to share with you about that. Impressed current supply electrons to it. They will help slow down the losing of electrons. And use of stainless steel, I want to rearrange the packing structure so as to improve the corrosion resistance of stainless steel. Okay, so this is what I would like to share with you. And remember, why do we need to do such a lot of things? You have to choose. Anyway, you have to pay because you are now going to against the nature, right, of the iron. Iron itself, even though it is placed in the middle in the metal relativity series, they tend to form compound. But we would But for humankind, we would just extract that iron and find that a pure state of iron is very useful because of the hardness, because of the strength, high strength. I love to use it. But finally, the piece of iron object will finally go back to its oxidized form. While oxidized form is somewhat brittle, and it will affect not only life, affect the safety, etc. So that's why we need to do something, need to pay something for it to slow down that naturally occurring change. We call it a deterioration. We call it corrosion. Okay, we call that for iron, in particular, rusting. Can you get my point? So it comes the whole flow of this chapter. We all usually love to compare this with aluminium. Okay, we usually love to compare this with aluminium. What is that? So, have you ever made that comparison table in the previous lesson? Not yet?
Yes.
Yeah, comparison, you know it? So you may see the corrosion for, I will just go back to this, if you know it. So which means that the corrosion of iron and aluminium is different. Corrosion of aluminium is somewhat, what we call it as destructive. While for corrosion of aluminium, we call it a type of constructive process. In terms of what? In terms of durability. 襟用耐用性 Okay, in terms of how long the life it is, the life of the a piece of metal can be used as a tool. So corrosion of aluminium being constructive is because of the nature of oxide. The oxide is impermeable to oxygen and water. That will help, it serves as a protective coating, right? So oxygen and water cannot go into it and reach the aluminium. And you may use this method. It's not just platinum, but also aluminium is also okay to produce that type of chemical reactions to enhance the corrosiveness. It can be done by increasing the thickness of oxide layer. Okay, again by electrolysis. I put aluminum oxide as an anode. I put it inside the styrene sulfur acid, and we have got some chemical reactions to form oxygen gas. While the oxygen gas to rapidly react with aluminium to form aluminum oxide to make the oxide layer thicker. While during the process, the oxide layer is quite funny. It will eliminate with that structure. If you will take a look at it very closely, we've got some hole inside. While they are setting as a coating to seal the surface, we try to make use of this time to add some dye to it. And we would have this dyed anodized aluminium product. Okay, it's during the process what we are going to do. They will help absorb the dye. Do you see why? Okay. Now remember, hardness is not the correct answer, but for surface hardness, her surface hardness is okay. Corrosion resistance is okay. Strength will not be increased. Okay, will not increase the strength. And the oxide layer to help absorb dye easily, so we will get that different color. Any questions? Now, go back to MCs. We have got the quick start. Have you done that? Have you done that all MCs? Not yet? Let's have a try. On question 2, 10 students should be ready. I just want to double check who doesn't answer. Trần Nói Thành. Question 2. Page 130. Question 2. What do you think?
Okay, let me think. I think it is no. Wait. I think it is B.
You think it's B? Why? Why is it B?
Actually think it does.
What is
Like,
the control? What's the control? Which one is control? X, Y, or Z? One of them is
Z.
E. C is a
Z
control. Yeah, so this is the reference point. It is a control. It's the control. So that 3 iron nail will finally rust. Okay, this is the reference point.
Yes.
So for comparing X and Z, you will know that these two, which one will have a faster rusting? Is X, right? Why?
Yes. Because the silver nitrate is can increase the electrical conductivity of the water, which makes it easier for electrons to move from iron to oxygen.
Or you think that it is a type of electrolyte as ionic substance, right? Ionic substance, it will increase electrical conductivity like this.
Correct.
Okay, so you will speed up rusting. What materials makes iron? For iron nail, it's iron, of course. Iron and silver iron, what happens to it? What is the chemical reactions?
Iron two ions and silver.
Yeah, iron, 2 ions and silver. So that reaction, is it rusting? Is it rusting? No. What is that for?
Displacement reaction.
Yeah, when you compare with rusting and displacement reaction, which one is faster?
Displacement reaction.
Yeah, so that's why X is fast, it will be corroded faster, and Z is because X undergo displacement. Can you get my point? X is faster than Z.
Okay.
Yep. What's next? Is Y. Why is it? Why is it Y having a slower reaction than the control? If you use the same logic, right? Zinc nitrate will have got ionic substance.
Yes.
While you have got a ionic substance, we can speed up the chemical reaction.
Correct.
Yeah. So Y should be faster than Z, according to your logic, isn't it? So why would you choose B? Can you choose it again? It's not B actually. But A, can you get my point? Why? For A, X is a faster reaction because you're not talking about displacement. But Y is still faster than Z. But that Y, when you compare with X, is slower, is because it's just a rusting process. I just speed up the rusting process. Even though rusting is speed up, it is still slower than displacement reaction. So we will choose A instead. Is that clear? Okay, thank you.
Okay, clear.
Yep. 3. A gel contains this. An iron nail is put in the gel and corrodes a period of time, which of corrosion will not be observed in the gel after the iron nail corrodes. Choka. Hi. A, B, C, D. What would not be observed? Blue, pink, gray, yellow.
Gray.
Gray. No law, okay? It's gray because it has been corroded, okay? So no gray. But for yellow, it's a rust indicator color. Glue and paint is the test is a combination between iron 2 and hexacyanoferrous 3, and paint is a combination between hydroxide and phenolphthalein. So the answer is C. Question 4. Mr. Tang. All right. Question 4. What do you think?
B.
B. Dip in the paint and allow to dry. Which one will rust most quickly? So what's the principle? 1, 2, 3. The first 3. They also apply protective coating. No matter what method they are using, right? Grease, paint, electroplating, although they are just protective coating. How about D? D. Wash with soap and rinsed. Soap to clean away what? To clean away grease. Especially people love to or maybe in the air where have got different materials and it gives no protective coating. So D will rust most quickly. Dang Junhei, question 5. Junhei, are you here?好似好困難咁啊！你哋啫。Question 5.
B.
E? Okay, is it?
Yeah.
Rose after spy. Again, presence for ionic substance, you mean?
Yes.
This one, no. How about the other two? C and D.
D is the cathode protection. D is the cathode protection.
Cathodic protection. You mean it like this? What is meant by cathodic protection? It's D. Many of you say D. Why? Because it's plus, it is minus. What is the direction of electron flow? Instead of having a cathodic protection, this is a process which speed up the losing of electrons.
It's anodized.
Yes, it's another way around. So for aluminium can be anodized to make it make the surface harder. You can improve the corrosion resistance. But when you do the same thing for iron, iron once it has been anodized, it will become brittle, and all those will be broken apart because the rust is somewhat porous. Porous means what? They can be easily react with oxygen and water because of the structure. Okay, the structure is not so firm. Okay, it's not so tough. Can you get my point? It's rather loose structure. So you may see that when you compare with B and C, C is faster than B, while the D is much faster than. Okay, can you see the whole flow? So the answer is D. Well, this one, the last one, A, will remain very, very slow because no ions, no present move ions can be found. Nam Seng Hon. Question 6.
Copper.
Copper, yes, that's right. No, cannot be used. If you want to speed up the corrosion of iron instead. 7. It's incorrect. Choose the one is wrong.
A.
A, okay. Galvanization, which means zinc. Zinc ions, they are toxic. So never put it in the food can. You'll be intoxicated. Question 8. Hoàng Nhật Long. Hoàng Nhật Long, are you here? Hoàng Nhật Long.
係睇緊。
係。The reactivity of aluminium is compared. Or can I have the other 3 students please prepare the final 3 questions? Long, like question 9, Lý澤星 10, and吳漢一 11.
B 啊。
Question 8 is B. Yes, correct. We've got a coating of aluminum oxide, protective coating. 9. Question 9. Who answer? Question 9. Is it long, like? Question 9.
I think it's B.
Is B correct? Anodize the deposition of the aluminum oxide. Question 10. Lý澤星. Lý澤星, what do you think?
Boy.
You think it's boy? It's boy, for example, but of course you think so, but iron 3 ions are also present. The answer is D. Ions are present in iron rust. Why? Iron 3 hydrated form. Hydrated iron 3 oxide. 呢度未有 iron 3 The answer is D. Thought so much. Final questions. Monja. Which of the following are the advantages of using the anodized aluminium? Common misconception here, right? Is C. Remember, the strain cannot be increased. So this is somewhat I would like to ask you guys to put a star here. Okay? So in short, here comes the revision of rusting. What do you think? Can you get the whole logic about this chapter? More related to the daily life. Okay? And of course, this should be backed up by some chemistry. And I'm sure your teacher, Mr. Lam, has taught you something more about the way to answering the long questions. Okay? I'm sure you can have an easier life in your chemistry quiz this week. When you're long, don't pretend you don't know anything. You can escape having the chemistry quiz soon. This Friday, chemical reactivity, and next Friday, that is rusting. Okay, I'll give you 2 weeks time to prepare, and next upper lesson, we will go over with you on the mole calculations, the last chapter in 1C. We go back to chapter 12. Exciting one, and we'll have got lots of quizzes. Okay, for chapter 12. Okay, I'm sure you will have a easier life. Okay, add oil and good luck. See you guys. Bye bye.